Hello everyone and welcome to Thinking with Mathematical Models 2.1. Our targets today, we want to be able to fit a line to data that shows a linear trend, write an equation for a line based on a graph of a line, and then use mathematical models to answer questions about linear relationships. Our ACEs for 2.1 are going to be 1 through 3 and 35. And as we get started here, it says we want to model linear data patterns, and organizing displaying the data from experiments such as tests of bridge strength helps you to see patterns and make predictions. And we have example table and graph from back in investigation 1 when we were finding bridge strength based on different thicknesses. This may not match up exactly with your data, but it's the data we're going to use for this exercise. So bridge thickness layers 1 through 6 and their breaking weights, those have been plotted on the graph. Now, as you can see, this wouldn't make a completely straight line. So a lot of times with scatter plot data like this, what we want to do to get a linear representation of it is to draw what we call a line of best fit. And that's what we're going to be working with here in investigation 2.1. Down here in part A of the problem, they've drawn two different lines. Both of these graphs are the exact same. They've drawn two different lines of possible best fit, okay? It asks us which of the two lines seems to fit the data better and explain your choice. And do you think that you could sketch a better line that's a better fit than these two, okay? So that's the first part with A. Then when we get into B, we're going to use our table data here. We have our different thicknesses, we have our different actual breaking weight, and then what's happened is we've come up with a model or an equation of y equals 10.4x plus 1.6, which is this line right here. That's the equation for that line. So what you're going to do then is plug in the different layers into the equation. So if I plug in the value of 1 for x, we'd have 1 times 10.4, which is going to be 10.4 plus 1.6. Well, 10.4 plus 1.6 is going to wind up being 12. So I would write 12 right here on my table. Second one, we would take number 2 and put it in for x. So 10.4 times 2 is going to be 20.8 plus our 1.6 is going to be 22.4, okay? I'm not going to fill out the whole table for you, but now you have an idea of how this works. You're going to fill out the rest of this table, and then we're going to find a residual. This residual tells us how accurate our model is, okay? And we want to be as close to 0 as possible, and when we go all across here, the closer to 0 we are, generally the more accurate our model is and gives us a better prediction of whether our line is good or not. So we want to take actual minus predicted. This line up here is actual, these are predicted, so 12 minus 12 is going to be 0. Okay, this one is going to be 18 minus 22.4, which is going to give us a negative 4.4. Okay, once you get all of these figured and figure out all of your residuals, you're going to add it together all the way across here and then put your total of what all of these residuals are out here and see how close that is to 0. Now you may say, oh man, that's a big table to make and whatever. No worries. On your homework rubric, I have provided you with the graphs and tables so you don't have to make them yourself. So if you don't have a homework rubric yet, make sure you get that from me. Okay, number 1 says first line goes through points 112 and 664. This gives us the equation of this. How would you describe the errors of prediction or residuals for this model? So we did it for the first one, figure 1. Also going to do it here for figure 2. You go through it the exact same way. And see which one you think, once you get your total here, which one is closer to 0, okay, and which one you think is going to wind up being the best model here. Okay. Then in part C, it says we could do this for other jobs too. Here there's painting jobs, different square footage areas of paint and how much time it takes. So they want you to plot the given area on a graph, draw a line, find an equation, and find your residuals for this table as well. So do all that, and then we have aces 1 through 3 and 35. Let me know what questions you have in class.